Okay, so now that we've talked a bit about the AsyncTask framework, I kind of introduced what it was about, what problems it solved. Let's start diving down into some of the key methods that the AsyncTask class provides. And you'll see that there's actually a fairly large number of methods, so you don't have to know about all of them all the time. These methods are divided up into two different types, two different categories of methods. Category one are the public methods, and these are the methods that the client application can actually invoke. So these are things that you could call from a client application. So as we'll see here, one of them is execute, which is the most common way of interacting with an async task. What you do is you say, start this task running with these parameters, which are optional, but you often have parameters. So you can start things running, and that's probably the most common method in normal use cases. Ironically, for our programming assignment, we're actually going to use this other method, which is very similar. This is called execute on executor. The difference is that in this case, we give it an executor as a parameter. So in this case, it's going to use the default executor, and in this case, you give it an executor to use. And I'll talk more about what default executor means. The executor here is exactly like the executor that you've learned about in the earlier parts of the assignment when we talked about the Java executor framework. So it could be a single-threaded executor, which would be a little weird. You could use a thread pool executor. You could make your own executor. There's all kinds of different things you can do. There's also kind of a weird lobotomized front end that just allows you to pass runnables to an async task. Very bizarre. You probably wouldn't want to do this. If you're going to do this, you might as well just use the executor. But it gives you a way to do that. So what was happening with cancel is you can attempt to cancel the async task, and the async task will be shut down if there's a way to shut it down. Recall from our earlier discussions about managing the thread lifecycle that cancellations of threads are always voluntary. And so if the thread that's running the task decides just to blissfully ignore interrupts, then this won't actually do anything. But it'll try its best to cancel it. So I'll show you some examples of this later. And as before, you can give a flag that says, should we interrupt it or not if it's running? So those are the main methods that are public. There's also some protected hook methods, and these can be overridden by the application developer and invoked by the async task framework internally. So it's really not so much overridden by the apps. I guess it's overridden by the apps, but it's overwritten by the application developer to customize certain things that happen when the threads run. So let's talk about each of these. OnPreExecute runs the user interface thread, runs in the user interface thread before doing background, and it provides an opportunity to do anything you need to do in the user interface thread to initialize stuff such that when the background thread starts to run, the world is in the right state. So a classic example of something that would work this way would be to, say, pop up a dialog box that says, downloading file, then start downloading the file on the background thread. Remember, the dialog box that pops up has to be popped up in the user interface thread for the reasons we talked about earlier in the previous lesson, because of the constraints of Android for not having things working in the background, accessing the user interface views and UI toolkit components. Doing background is actually the workhorse method that does all the work. That runs in the background, and it takes some parameters, and it does the computation, and then it returns a result. There's also an interesting method called OnProgressUpdate, and this is going to run in the user interface thread after the publish progress method is called. That's a method that's called by doing background in order to notify the UI thread something needs to be informed to the user. So as a simple example, let's say you were downloading a big file and you want to be able to update the progress bar, right? You've probably seen a progress bar or a progress wheel. And so you can call publish progress to indicate how far along you are, and that gets published, that gets presented to the user interface thread by calls to OnProgressUpdate. There's also OnPostExecute, and OnPostExecute is going to be run in the user interface thread after doing background. And so remember, do in background is running in the background. When it's finished, it returns a result, and that result is passed to OnPostExecute. So that allows you to undo something in the context of the user interface thread after the asynchronous task finishes running in the background. So you might tear down the dialog box that said downloading, or the progress box that says downloading image or whatnot. Likewise, if a thread is canceled, or if the task is canceled, then the OnCancel method will be called back instead of OnPostExecute. So this occurs when cancellation takes place. And that's also a way to inform something, the download was canceled, right? And that'll take place in the user interface thread. So these are the hook methods. And if you recall the template method pattern, you can think about this stuff sort of in the context of the template method pattern. The AsyncTask framework invokes these methods at different points of time and in different thread contexts. So you can see here, when you invoke execute, that runs in the user interface thread. And you can see that the OnPreExecute method runs in the interface thread, user interface thread. OnPostExecute runs in the user interface thread. And OnProgressUpdate runs in the user interface thread. So these are all things that are running in the user interface thread. And then do in background runs in the background thread, as we'll see. So let's see, I guess that's just going through what we just talked about. So what this implies, of course, is that if you're going to be using the async task, you have to override the hook methods. And the way this works is you come along, surprise, surprise, and extend from async task, which could either be made by making a new class, or it could also be done by making an anonymous instance, an anonymous inner class. And then you go ahead and override the methods you're inclined to override. As we'll see, you have to override the do in background method. This is the one that's abstract. If you don't override this method, then you can't instantiate an instance of the async task that you've got. So that has to be overridden. The other ones may be overridden. So you can see I put do in background in italics to indicate that it's an abstract method that has to be overridden. Execute is called once per async task by code in the user interface thread. This is implemented as a variant of the template method pattern. Hopefully you remember that from classes you've taken before. Remember, template method pattern says define the skeleton of an algorithm and then allow the steps to be overridden by subclasses. So that's what the template method pattern says. Execute on executor is like execute, except you give it an executor to run, and that controls where the pool of threads will execute. By default, if you don't do anything to the contrary, then all the async tasks in a given process run sequentially in a single background thread. And I'll show you a bit more about how that works a little bit later. As I mentioned, this is executed by the UI thread to do stuff before we run in the background. Do in background runs in the background. And it runs the task at the background thread priority. So by default, background threads don't have as high a priority as user interface threads. And that's because Android is optimized for responsive user interface interactions. So if you don't like that, you'd have to change the priority of the background thread by using thread priorities, the set priority methods. So you can do that, but that's not what it does out of the box. As I mentioned, OnProgressUpdate is invoked while the background thread is running when it calls publish progress. OnPostExecute runs when we finish successfully, and OnCancel will be called when you cancel something. So if you cancel the thread, then if it succeeds, or actually after you cancel it, it'll call the OnCanceled method instead of calling OnPostExecute. And these are mutually exclusive. If OnCanceled is called, then OnPostExecute is not called. And if OnPostExecute is called, OnCanceled not called. So they don't both get called. And what you should do when you write do in background is, as with normal threads, as we discussed, in your do in background method, you should periodically check to see if you've been canceled. So there's a method called isCanceled that can be used to check to see if you've been canceled. And if you've been canceled, you should go ahead and shut down, which makes sense. So this is very similar to using the Java interrupt method, and I think under the hood it probably uses that. AsyncTask is a generic type, and it's parameterized by 3 other types. And the types are params, progress, and result. Let's talk about each one of them in turn. Params is the type used to pass input to the background task. So when you call execute, when the execute method is called, you can optionally pass it parameters, and those parameters will be passed into the doInBackground method to run in the background. So that's how you get work into the async. That's one of the ways you can get work into the async task. There's also progress, which is the type that's used to convey from the background thread to the user interface thread as incremental progress is being accomplished, is being made. That's usually something like an integer, because you might want to say, percent complete. You could pass an integer as percent complete. You could also pass a string or whatever, as long as you put the type in there. And then the last type is the result. So that's the type of result that doInBackground returns and which gets passed to OnPostExecute or OnCancel. So whatever the result of the task is, you can get that passed appropriately. Here's a very simple example just to kind of illustrate how this could work. So we're going to have download task, extend async task, and you can see it's going to give a uniform resource identifier, a URI, as its first type. That's the params type. That's what's going to get passed to doInBackground. You pass in the integer to indicate what gets passed back to the user interface thread, as we call publish progress. And there's a long, which is the result type of this thing. So here's how this is going to work. When we execute an instance of download task, passing in a download URL, so that's the URI that we have up here, that is going to end up calling doInBackground with that URI, and it'll go ahead and download the file. Then, as we're downloading, we could have the doInBackground method periodically call OnProgressUpdate, indicating we're 10% done, we're 20% done, we're 30% done, and so on. And then when we're all done, we could call OnPostExecute, and that would go ahead and indicate, we downloaded 100 bytes or 1,000 bytes or 1,000,000 bytes, whatever. You'd assume that doInBackground would return the size of whatever it downloaded as its parameter, which is a long, which gets passed here. Okay, any questions about that? Now, so that's the end of the overview of the key methods. For your programming assignment, for various reasons, we're going to have you override those hook methods. And in particular, the OnPreExecute and OnPostExecute methods, what you're going to do is you're going to just log the fact that they were called. And that's because, for various reasons, we already handle everything else we need in the framework for this stuff. But I wanted to give you some experience doing something that would have a side effect that you could track and trace by looking at the output of the logcat window in Android.